So we are talking about dx equals to ax plus bt, right? We are talking about dx equals to ax plus bt, and we discussed about the generalized solution. So, and I promise that today I will be discussing an example problem on dx equals to ax plus bt. We look into it. So, dx dt equals to ax plus bt, and we have done that p multiplied by p inverse, everything has been done, and the generalized expression we got dy dt equals to jy plus gt. If the A matrix is having distinct eigenvalues, then J will be reduced to lambda matrix. Lambda is the diagonal matrix, and lambda to the eigenvalues. Okay, and the A matrix is non-symmetric. Eigenvalues are not distinct. In that case, we get J matrix, where the off diagonal terms are not zero, and off diagonal, super diagonal will get one or in different places. And we have solved this problem using the integrating factor method. And last class we got the expression for xt. What is the expression for x bar t? Anybody can dictate for me? 0 to t integral 0 to t p matrix e to the power j minus tau g bar tau d tau plus p e to the power jt p inverse x0 which is initial solution. Okay, so this is the entire solution. So this technique would work fine. Okay, and the main challenge is to calculate e to the power jt. And e to the power jt calculation is straightforward. It seems it may not be straightforward, because j would be decomposed to j1 plus j2. J will be decomposed to j1 plus j2. Okay. So in that case, if the j1 j2 commute, it will be fine. If j1 j2 will not commute, this entire procedure will not be okay, because calculation of e to the power jt will be cumbersome. In that case, we have the last weapon to go for the direct method. That I will going to discuss next. So let us take one example problem, which is from your assignment. I think assignment number, which assignment? 5. Okay. Which is dx dt equals to ax plus b. And the eigenvalues are, we found last class, 2, 2, 2. Matrix A is given, which is 1, 1, 1, 2, 1, minus 1, and minus 3, 2, 4. And lambdas are 2, 2, 2. Okay, and it is quite obvious from here. This is a non-symmetric matrix. All eigenvalues are same. First bench sir, you are really enjoying life. You don't have assignment. You don't have assignment. So you will take how many years for MS? Do you have assignment or with you or not? Okay. So why you have come here then to see the drama in the class? Yeah, it is quite obvious that why you are performing like this. Your attitude is actually telling. See, to perform well in the class or the research, we don't need good students. If the students are good, sometimes I feel a problem. But sometimes I feel the students are sincere. The students are even not intelligent, they are performing better. Because I am not an intelligent person. My rank was mediocre in the class. But I think I am doing okay, I am not doing bad. Because of what? My attitude was not like you. Okay. So you know that what are you doing and what are you going to get. I will not do anything. You are doing everything. Okay? Fine. Thank you for your attitude. I appreciate it. Okay. So this is assignment part 5. Assignment 5. Which problem it was? Do you know the problem set what I am talking about? Which problem? Assignment 4 or 5? Which assignment? Tell me. Let's see the situation. I am now asking assignment. Giving the problem, asking assignment number. Which assignment? Any hands please? 4. You are saying assignment 5 and our friends don't have any assignment. You don't have any money, sir? You don't have money. How much is the Xerox this thing? Costs here. Each page Xerox cost how much? 1 rupee. Okay. So it is 2 pages or 1 page? This is assignment 4. You don't have assignment 4. See? That time you are laughing. I don't know whether you are laughing or bluffing. These two are very nice words. You are doing PhD. You are doing MS. You are made for each other. That's why you are sitting next to each other. I really enjoying the class with you guys. Your sincerity, I really admire. Where from you have done master's, sir? IIT. Okay. You are coming from one and to other IIT. Same system, same atmosphere. I appreciate it. So you are maintaining the atmosphere. Okay. You are saying any problem, assignment? You are searching the assignment is there or not. Okay. So that's what I am not giving any part mark. Because you also don't want to give any part mark to me. Part mark means you should carry the assignment. That is the marking for me, right? So if you don't give part mark to me, how can I give part mark to you? Now you can see why I am not giving any part mark. First of all, because we don't know the next year will be there in the institute. You may not be there, right? Because gate exam and all, but it is doubtful. Some of my students told me, top 250, right? You will get job. Top 200, my senior MD, you can contact him, he has all the information. He is the consultant for you guys. Top 250 will get the job. And there are so many IITs and so many BTECs are actually competing, I have heard. And there are a lot of coaching centers also, like I am giving the coaching here freely. All IITs are giving coaching, professors. So, those people will be competing. So, it is not likely that you will get top 250 rank. If you don't get top 50, 250, you have to be in IIT. The problem is, if you don't get good CGPA, because we are definitely going to give E grade, not U grade, if you are not doing well. If there are 2 E grades, that's what opponent told me, CGPA will come down to below 6.5. And with 6.5 CGPA, scholarship also will be cut. So many things will be consequences, I am telling you. You will prepare for gate or you will appear for gate. But the point is, all those things are fine. It is your human right. I am not saying you don't appear for gate at all. But I also have my human right. My human right is I will be doing justice. Why to give part mark and why to show my kindness for you? If I show my kindness for you, you will take me for a ride. It happened to me. These matchmates have done to me. Okay? So that's what. So you have your human right. I will have my human right. Let's see whose human right is better. Okay? That is the thing we are doing in the class also. See these people, they are, you have human right not to give the assignment. I am not shouting about you. I am really appreciating. I am just seeing your human right. See, sometimes what actually happens, your human right will not change. Okay? You will be doing whatever you want. But my human right will change. Because last year for their class, I was giving part mark. That was my human right. Now my human right has been changed because of this attitude. But your human right will be always same. It's an interesting problem. The control problem. The feedback loop will be there. Input is there, output is there. In a feedback loop, so human right, all those things will be coming. You can actually design a controller and you can actually talk on that. How to improve the entire system. Okay? So we'll discuss better about that. So he's a very intelligent guy. So he's willing to do all those things. Okay? You also don't have the assignment. Okay. This is which assignment? 4, 5. Problem set 4. Okay. That means if you eat, they will also eat. Only you will be going to this. You don't have to go to this, you don't have to go to this, right? Okay. So only one person will be eating. Another 2 will be getting food. Same thing for you also. One will be eating. Okay. Another will be getting food. So this is a very good kind of social life. I really enjoy. Okay. Now eigenvector. What is the original eigenvector? 0 minus 1. 0 minus 1. Okay, so I got minus 0, 1, minus 1. Doesn't matter. Okay, because alpha you multiply, alpha into minus 1, it is 1 minus 1. Minus 1, 1. Now generalized eigenvector based on this. How to have generalized eigenvector? So generalized eigenvector is A minus lambda I Q1 equals to Q1. This is my generalized eigenvector. So you can take 0, 1, minus 1 and then what will happen? What will be your final equation? What are the things you will get from here? Who can dictate me? No, I want the equation. Two equations will get and three unknowns are there.
Q1 equal to Q2 plus
Q1
Q1 is equal to
Q1, how Q1 will be there? Q1 has not a problem. That's what I'm telling you. Your attitude has severe problem. Q1 vector is what? See my situation. I have to write this thing. This is so unfortunate. After doing so much, I have to write. Otherwise, you will tell something stupid. Okay. Anybody can give me the equation in terms of these variables?
Q1 minus Q11
Minus
Q11
minus Q11
plus Q12
Q21
okay Q2
Q31 equals to 0. Next one?
2Q11
No, Q21. So basically what you are doing, you are not doing the echelon transformation. That's why you are getting Q31. That means you don't listen to me what I teach in the class. If you don't listen to me, this kind of problem will come. How to get the eigenvector? If you want, I can do the steps, but that will be unfair. Because we need to write A minus lambda Q1 equals to U1. Then the situation is you have to do the echelon form, and based on the echelon form, you can get the two equations. Otherwise, you will get three equations, and it will be thinking the unique solution. That is not correct.
Q21 plus Q31 is equal to minus
Q21
plus Q31
plus Q31 equals to 1. Yes, not minus 1. Equals to 1. Because my eigenvector is this one. I have given the eigenvector. I have given the eigenvector. So, what will actually happen? What will be your generalized eigenvector then? What will be Q1 bar? You can see that there are two equations and three unknowns. There are two equations and three unknowns. The first time we are actually evaluating generalized eigenvector. We are not evaluating radial. That's why I wanted to show all the steps here. I want to show all the steps here. Because first time we are evaluating the generalized eigenvector here. The first time we are evaluating generalized eigenvector here. What will happen? 1. How many is a vector quantity? You are saying 1. And then
minus 1
that is not correct. First element is 1 is okay. Other elements are not correct. What you are saying? Again you are saying 1. Just keep it. Don't get confused. I want all components. I want all components. All the components. What is that? Have you enough time? Two equations are given and you are not able to find the solution. I don't know which class I am actually doing this kind of thing. This actually should be done in 1 minute. What's the problem? Something you have to assume and then nothing you have to solve. Huh? 1 minus alpha and what you are saying? It is not 1 minus alpha. Alpha should not be the eigenvector. What are you talking? Alpha should not be the eigenvector. Is there alpha there in this eigenvector? Then why am I saying alpha will be there in eigenvector? Yes, yeah. The name is Amit, right? You cannot find us eigenvector, general eigenvector, come on. What I am doing in the class, I don't know then. You are saying I will be doing it, what is this? What are you doing? You don't look at him. He is not the the expert. Is he your teacher? Then why are you looking at him? Any problem you can talk to me. He won't give you the solution. Only me will give you solution. He won't give you solution. What is the problem? One is there. One already gave, 1% gave. Then what is that? 1 or 0. We can take plus alpha 0, 1 minus 1, whatever. But this is 1 is actually fine. Okay. Next is, if you take this one, 1, because this is actually simplified thing to satisfy this equation, right? Next is, we can have another one also, no problem. Q2 equals to Q1. What are you getting? Q2 equals to Q1. What are you getting? So generalized eigenvector is not unique, right? Generalized eigenvector is not unique. You can take either of this. I am taking this one. Other one also you can take, no problem. Generalized eigenvector is not unique. That's why they cannot form the basis. We don't know what are the things that will happen. Eigenvectors are unique, but generalized eigenvectors are not. Unique in the sense they have the particular direction. Okay? And these satisfy this equation also, right? So it doesn't matter. What is the next one? You do the echelon form. What else? What are the equations you got from this? There will be two equations, right? Yes. You will get the equations. Pardon? Minus Q21 minus Q21 plus Q22 Q23 equals to 1. Then next one Q22 plus Q23 equals to 3. Correct only. Not a problem. These things are done by echelon form, right? And don't ask how to do echelon form. We have done so many times. You do the upper triangular matrix. You do the row elimination form. You get the echelon form. Okay. And then from this again you can see this is having 3 variables and 2 unknowns. We are having 3 variables and 2 unknowns. Pardon? How much is that eigenvalue? Eigenvector Q3 equals to 230. No. Is satisfied? Okay. Anybody else is getting some other eigenvector? What is your complete eigenvector in terms of alpha, beta, or something?
0 plus alpha into 0 minus 1.
Anybody else having anything else? What are the eigenvectors from here? 2 to 1 someone is getting. Slightly wrong. It's not 2 to 1. Who got 2 and 2? How did you get it? Huh? 2 to 2 equals to 1 you got. Okay. Oh, okay. And then? So what actually he did, he has done very smart way. What he did actually for this problem, that was my guess. I have my eigenvectors are here. So he did, you did Q2 equals to 1, right? So your Q32 equals to 2. Okay. So 2, there it is 1 and is minus Q1 2. Automatically he got. So this is one of the smart way he actually got it. There could be many ways you can take it eigenvectors. Only thing is he has to satisfy. Okay. There could be many ways. I am just picking a particular eigenvector because I give the solution on that way. Otherwise you can have many ways because there are no uniqueness of the direction of the eigenvector. Because simple eigenvectors have the uniqueness of the direction. But the generalized eigenvectors are, that's what, they cannot form the basis. That's what I said. They cannot form the basis. In many ways, you can have these two equations to be satisfied. This is one of the ways. So don't mistake me. This is one of the ways. In any ways, you can see this is satisfied. Okay. So you have got generalized eigenvectors Q1 bar and Q2 bar. And now, what is your P matrix? Now you have to construct the P matrix because this is your solution. So I don't want to disturb this side. I will see, you need to get the solution for each part. We have got the eigenvector That means P matrix can be constructed. What is a P matrix? First column is the eigenvector. What is that? 0, 1, minus 1. Second column is the first generalized eigenvector, which is 1, 1, 0. And third column is 1. Okay. So now this P matrix can be obtained. So sometimes what actually happens, if you want to verify your other generalized eigenvectors are correct or not, in that case you have to put P, then P inverse AP, then if it is J, you can say okay, my J configuration is fine, so those vectors are fine. So in that case, if you want to know these generalized eigenvectors are correct or wrong, you can actually calculate P inverse AP, okay, manual, okay. So if you have the, so now we have the P, and so what is P inverse? How to calculate P inverse? How much is P inverse? Answer. How much is P inverse? How much is P inverse? How to calculate P inverse efficiently? 1 by determinant? P inverse is what? How much? 1 by? Yeah. How much is that? We have got this formula actually already given. Last so many classes back, I get the formula. If you just go by the formula, can you get the answer? P inverse, I want the numbers. I want the numbers. I have given the formula long back, right? But those formulas are derived for the lambda matrix. It should be valid for the J matrix also, right? Those formulas we have actually derived for the lambda matrix, which is diagonal matrix. That could be valid for the J matrix also. Let's look at if it is valid for J matrix, we should be getting the correct number. What are the numbers? P inverse. P inverse numbers. Anybody can give me column wise or row wise? Anybody can give me column wise or row wise the numbers? P inverse. So getting something from you is very difficult, it seems. Getting some answer from you is very difficult. What happened? Yeah. Huh? So first row. First row, how much you got?
Minus 2.
Second row?
3 minus 1.
Third row?
Minus 1. 1.
How do you do it? What is the formula you use? You do the enough work? Okay, you have to use the calculator. That is dangerous actually. So you have learned how to cheat the system. You have learned how to cheat. That's why you know this kind of steps in the exam. If you show the calculator, don't show the steps, I will give you 0. He cheated just now. How he cheated nicely? He used the calculator and get it P inverse. I found he is very, very intelligent. See, you know cheating also. I didn't know that how nicely you can cheat. So in that case, if you don't show the steps, marks will not be given in the exam. Good, thank you very much, because I didn't know how to cheat, because I don't have this kind of iPhone or calculator. And I don't use calculator. Another problem. I don't know how to use the calculator. Okay. So this is the answer he got by cheating, but any of you got the answer by the calculation? Zero will not be this is the answer he get. This is the answer he get. Answer is the correct answer. But if you follow the technique, the method actually I have given, is that the right answer? Are you getting? Yes, Amit.
It will not give the right answer because the eigenvectors are not off.
Eigenvectors are not optimal. That's okay.
So it will not give the right.
Okay, then how to get P inverse?
One upon determinant of.
One of determinant or. That's what I wanted to say here. When you say P inverse AP, don't work. That's what I said. It may not work because they're not orthogonal. Okay. And the thing is that how to calculate inverse quickly if you don't want to do the determinant calculation. Because here determinant calculation is very, very complicated. because so many terms are there, I may do mistakes. So I will give you the shortcut way. Is I matrix, right? So P matrix could be A11, A12, A13, and it is A1, A2. Sorry, A31, A31, A32, A33 into A11 prime, A12 prime, A13 prime, A21 prime, A22 prime, A23 prime, A31 prime, A32 prime, A33 prime. It is equals to 100, 010 and 002. Okay? We have to find out this. We know A112, A13. So take this matrix and take the column, you get this column. Take this matrix, take the column, you get this column. Take this matrix, take the column, you get this column. And every time we will see this will be unknown. We will like X equals to B. So that means we will get this kind of thing. A11, A12, A13, A21, A22, A23, A31, A32, A33 into A11 prime, A12 prime, A13 prime equals to 100. Similarly, we get other columns also. This is not known. This is known, this is known. This you can do by Gauss elimination, right? This calculation. This is very easy calculation. Right? With that you can get A1 price. So like that you can get P inverse and chance of doing mistake is much less. It may be a tedious process, but chance of doing mistake is much less. Okay? I don't know first when you would understand because you have the calculator for the cheating purpose. But the point is, if you don't show the calculation, I won't give the marks. So you give it like straightforward 0 marks. So any of you got it finally? P inverse. Because if once you get, you have to tell me how you got it. See my situation now, I have to struggle so much to get P inverse from you guys. Where I have to do so much details. Because P matrix looks like very straightforward because if you look at it is 1 minus, if you just add it up, you get, and here this is already 0, so what you can do that, you can actually swap this when you do the Gauss elimination. If you swap it, what actually happens, that all those things will also swap, you know, it will be 0, 1, 0, right hand side. So you have to get the correct answer. So what I will do that, I will not spend much time here because I will assume that we will be able to do B inverse because in this graduate course I should not spend 50 minutes for calculation of P inverse. It will be ridiculous or dangerous for the course. So I will actually assume that we can calculate P inverse. With that assumption, we will just see that how this entire calculation is actually done. So what is your J matrix then? How the J matrix will look like? Because we have to come to the business, P matrix is there, e to the power J is there, so we have to know J matrix. How the J matrix will, because why I am doing this calculation, because this kind of problem is going to come in the exam. That's what I am doing in the class. You may be feeling bored, but I can't help it. Because exam, this kind of problem will be coming. You will say I am feeling bored, because some of your guys actually could not write in the first test. They will be getting 0. Saying, oh, if you get bored in the exam, it is dangerous, because you have a high chance to get 0 marks. Unless if you don't mind, it is okay, maybe. J matrix. How the J matrix will be? Pardon? How much you got? 2001? 210? 02? Did you verify? Can you verify it? There's another thing. So if this, see there is no catch. If P inverse calculation may be wrong, okay, or this general eigenvector could be wrong, we don't know. If this one of this is wrong, it will show up here. Because sometimes you may get some other number you cannot get, or you may not get. You should not get 0 here. If you get 0, some other problem. Both these guys have to be 1. Both these guys have to be 1. So you have to be very, very particular here. Both these guys have to be 1. And it's because we have only one Jordan block here. We cannot have multiple Jordan block. Okay? The number of Jordan block is number of eigenvector. Independent eigenvector. Number of Jordan block is number of independent eigenvector. Okay? So only one eigenvector. and two generalized eigenvectors. Okay, I think you can, anybody is going to verify this? Anybody is doing the calculation? P inverse into A into P. Anybody is doing the calculation? Yes. Please do the calculation, because I am asking, because these kind of steps you have to show in the exam. You may be reluctant to do, I am telling you, fine. But at least one or two should do, because for exam purpose, 2 days before you have to go to somebody's room. If somebody is competent, who can help you. That's the way that 2 days before exam, people will be very active. And somebody has to do in the class so that you can get some help, otherwise problem, because I won't be available for consultation. Yeah, P inverse AP, are you getting this? P inverse AP. Are you getting this? P inverse AP? Yes or no? Yes? Simple matrix multiplication, I am just seeing that. Simple inversion you are not able to do. Somebody is cheating. Now P inverse AP, the multiplication of the matrix 2 times, that also you are not able to do. I don't know where I am going. It is coming. Can you show it to me? Because I am not asking that for verification. Because if you are correct here, soon your friends will come. So you have done the back calculation. Okay. But that cannot be the case. It should be, because this is another way of cheating. I am telling you. So you guys are actually showing me a very nice way of cheating. I really appreciate. But that will not work in exam. Because here I am not saying anything to you. Exam means I will give you 0. Okay. Because as I said that your way of handling and my way of handling, they are different. But your way of handling is independent event. Like independent eigenvector, and I am a generalized eigenvector. I will be depending on your attitude. So you are acting as, there is a classic example. You guys are independent eigenvectors, and I am always generalized eigenvector. I cannot be independent. Last year I was independent eigenvector. This year onwards I have decided to become generalized eigenvector. Because my attitude is depending on you. Okay. So if you change your eigenvector value or the direction, my direction also will be changed. Right? Okay. It's coming, right? What we have done, at least I want to think somebody has done correctly, so you can, yes. Okay, well, all the steps are actually shown. So you can get the entire class who could not do it. Okay, what is your name? Huh? Unvenched. 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 Okay. Yeah. So J matrix has been obtained. Now, for e to the power J2 calculation, what will be the steps? Because we have the off-diagonal system. Off-diagonal, see, if these values are not there, we are okay. But the values are there. That means this matrix has to be decomposed. How to decompose this J matrix? So J matrix can be decomposed to J1 matrix plus J2 matrix. What is J1 matrix? It is 2 0 0 0 2 0 0 0 2 plus. This matrix is 0 1 0 0 0 1 0 0. Question is the J1 J2 commute. So then after this, your next job directly not to calculate it for J2. You will calculate, your calculations will be done after the verification. The verification purpose, we have to see whether J1 J2 equals to J2 J1. Is it equal to J2 J1? Or J1 J2 square equal to J2 square J1? Or J1 square J2 is J2 J1 square? So all sorts of multiplication what are coming, that we have to verify. Is J1 J2 commuting? Yes or no? Is it commuting? Yes? Okay, 2 people told yes. Very good. That means you are very good in matrix multiplication. I am very happy to see that. So some people are very good in matrix multiplication. That is good actually sign. At least you can multiply nicely. So how to calculate e to the power jp then? Now I will be coming here. because all those things have to be done before going to the final step. Otherwise, you will get wrong result, and that is problem. You will be getting less mark in the exam, and also that is the problem. You don't want that. E to the power jt is e to the power j1t e to the power j2. Correct? J1 will be how much? E to the power j1t will be how much? E to the power 2t, e to the power 2t, e to the power 2t. 0, 0, 0, 0, 0, 0. Excellent. Next is e to the power j2t. How to calculate e to the power j2t? So you write down e to the power j2t. That is not done. So in this step, we will be doing e to the power j2t, which will be I matrix plus j2t plus j2 square by 2 factorial t square plus j2 cube t cube by 3 factorial and so on. So next step is 1 0 0 0 1 0 0 0 1 plus j2t. What is j2 matrix given here? T means 0 t 0 0 0 t 0 0 0. So it is 0 t 0 0 0 t 0 0 0. Next step j2 square. Somebody should do j2 square and give me the answer. Somebody should do j2 square because some of you are very good in matrix multiplication. At least they can give me the answer. Who are good in matrix multiplication? Some of you are very good in matrix multiplication. j2 square how much? 0 0. Then 0 0 0. So j2 square by 3 factorial will be t square 2 factorial. And then what will happen? j2 cube will be having 0. You will see that, you verify. That's the beauty of this method. That's why I told this method I discovered this decomposing during the TA work of the course which was offered by my PhD guy in 1994. That time I devised this method and I found this method is so powerful because you can decompose and slight tedious work is there, not much. And you can get it is 4 by 4 matrix means we have to do another one step. 5 by 5 means another one step. 5 by 5 means 5 steps. 3 by 3 means only 3 steps, like that. So for less number of systems, this method will work fine. For larger system, this method again tedious, and then you have to go for the direct method. So how much is equal to our j2t? Anybody can give any answer? What will be the final answer? j2t? 1 t then t square by 2. Then next 0 1 t 0 0 1. So you write here these values 1 t square by 2 0 1 t and 0 0 1. What is your final value? It will be for jt. It will be for jt. E to the power 2t e to the 0 no t square by 2. So you have to learn matrix multiplication. Okay. Without that difficult. 0 e to the power 2t t e to the power 2t 0 0 e to the power jt you found nicely. Okay. You found nicely e to the power jt. Now what else you need? You need to know e to the power jt minus tau. That you can get easily. In place of t, you can put t minus tau. What else you need? You get g bar tau. How to get g bar tau? So gt, have you got gt? So let's delete this part. This we don't need now. We don't need this one. Now we calculate gt. Now we calculate GT. What is the GT procedure? Calculation procedure? P inverse BT. B is given. What is B in the problem? T11. Excellent. GT, then P inverse minus 2 to 1, 3 minus 2 minus 2 minus 1, 1, 1, and T 1, 1. How much it will be? Calculation wise? How much it is?
2t plus
Yeah, somebody is saying some answer.
minus 2t plus
Minus 2t plus 3,
3t minus 4
3t minus 4,
minus 2t plus 2
minus
t plus 2
t plus 2. Some answer wrong thing is there.
minus
Minus,
minus
just a minute. What are we minus? Is it correct?
yes sir yes sir
Yeah, please do not confuse me. I thought my mathematics is so, yeah, I never got 100 out of 100 in mathematics. 99 I got. But if I would have done that much mistake, 99 also those people would have given. 100 I cannot get, I know, because my mathematics is not that good. Maybe some of you can get 100, but I would not get 100 out of 100. That's okay, doesn't matter. Okay, so G bar tau we can also put in place of T, you can get tau, G bar tau. So these guys are manageable now. This guy is known here, this guy is known, this guy is known. So everything is known. So we are doing now final step. So I will be concentrating much on this part because it is a bit complicated. Integral is there. These guys are easy. Let's look at that complicated fellow. E to the power j t minus tau g tau. This is matrix, this is vector. So this will be a vector, and this has to be a vector. Entire thing has to be a vector. Let's see what actually we are making. Because you can see this p can be taken outside the integral because p is constant. If you integrate and multiply with p, it will be better. So this is a smart way. Some of your classmates last time, your seniors, what they did, they put p inside and did the integration. Your calculation is a bit tedious. So p is a constant matrix. No, constant can be taken outside the integral. That's why I will be doing the integration now itself. So if I put the integration 0 to t, what I will get? First to tell me in terms of integral. Then we will evaluate the integral, okay? Who will tell me the integral? G is known, e to the power jt minus tau is known. You multiply and get me the answer. First row of e to the power jt minus tau multiply with the g tau. There is no row, only one column is there. If you multiply, what you will get? Minus. Who will give me the answer? If you multiply, what you will get? It is v tau. I have not written. I should write properly. Okay. First term will be what in the integral? First term will be what in the integral? My God. Simple multiplication you cannot do. It has come to such a situation, simple multiplication you are not able to do. What is the first term of this integral? Yes? Amit? You are lost. What you are doing? What are you doing? I am just really surprised. I am just surprised. You have to multiply the first term and get me the term. And you are saying you are doing? What is the first term in the J matrix? Amit, look at me. What is the first term in the jt minus tau?
e raised to 2t minus
Not e raised to the power.
e to the power t 2t minus
E to the power
2t minus
2 into t minus tau multiplied by minus 22 tau plus 3. Only that much I was asking. And you were saying, sir, I won't give the answer. Is it fair? I am telling you. I am just saying this kind of thing I have not seen. Vasudha, can you tell me the terms? You are not able to multiply the matrix element by element. What are you doing? What's the problem? Where is the problem? You tell me. This matrix is known, and this term is also known. Where is the problem? I just want the term by term and the integral sign. I'm really lost at a loss what I am teaching in the class. I am trying to help you to solve this problem in the class. Integral term will not be there. Say I put integral term. That's what if I do the same thing in the class, you will appreciate. You won't appreciate. What is the first term then? Integral 0 to t then minus 2 tau plus 3 e to the power 2t minus tau. I am putting a bracket plus. Yeah, nobody should talk because when I was begging for the answer, you treated me like dog. So if anybody talks, I ask that person to get out of the class. I am getting very angry here. And you were successful. I thought I won't get angry, but you were successful. Madam, please continue. You please call. If anybody talks or whisper, I will ask him to get out of the class. Okay, please.
Plus 3 tau minus 4.
3 tau
Minus 4.
Is it correct? See, we have t minus tau into 3 tau minus 4, right?
Yes.
What is that?
3 tau minus 4.
Minus 4
T minus tau.
and then
E raised to power T minus tau.
t minus tau
E raised to power
e to the power
2 bracket T minus tau.
t minus tau.
Plus
Nothing will be there. Are you sure? Plus
2 minus tau.
t minus tau,
2 minus tau.
2t minus tau, and bracket close. Am I correct? Yes, second page. Can you verify this? Yes, Agnes.
Last term is
E to the power whole square. What is that? Yes.
Into 2 minus 2 in front of
before T minus tau whole square 2 minus tau
2 minus 4 by 2.
by 2 into E raised to power 2T minus tau.
For getting this much, I have to really struggle. So I think what I was planning that I will solve this problem in the class, but it seems only 2 or 3 people are interested in the class. So shall I skip this problem to solve in the class? Of course I will skip because others will not participate. I will skip, that's all. Because you made me angry today. This is not correct. You made me, what I am doing I don't know. People are not interested. Next now. Can you help me then?
3 tau minus 4.
0 to t again.
0 T.
Yeah.
3 tau minus 4.
3 tau
Minus 4.
minus 4
E raised to power
e to the power
2 into T minus tau.
e to the power
2 into T minus tau.
2 minus tau
Plus
plus
2 minus tau
2 minus tau
into T minus tau.
t minus tau
E raised to power
e to the power
2T minus tau.
2t minus tau
dt. D tau. Whole bracket.
next term
2 minus
0 to t
2 minus tau.
2 minus tau
E raised to power
e to the power 2t minus tau.
d tau.
That's it. That's what I was actually asking. It was not that difficult. And I have to beg to Amit to give the answer. This is a very bad attitude I'm telling you. I don't know what for you are coming or I am coming in the department and teach you guys. It is nothing. Just to multiply that and put integral sign. I didn't ask anything extra here.